Yeah, today we have organic chemistry, and what we have in organic chemistry is nomenclature of organic compounds. In the nomenclature of organic compounds, this is the structure of an organic compound as an example of it. So we have the structure here. So for us to name this organic compound, first of all, we check the longest carbon to carbon thread chains. Then, in the straight carbon to carbon chain, we check from here to here. If you count it, it is 12. If you check from here to here, it's not up to 12. If you check from here to here, it's not up to 12. If you check from here to here, it's not even up to 12. Even if you check it from here to here, or from here to here, or from here to here, it's not up to 12. So from this place to this place gives us the longest carbon to carbon chain. So in this straight carbon to carbon chain, this is alpha carbon and this is omega carbon. Then the next thing we now do is numbering. In numbering, we take from the priority series of functional group the one that appears here that will carry the parent name of this organic compound. From the functional group priority series, we see that we have the highest priority series here, which is alkanol functional group, and we have it two here. We have one at carbon number 3, we have one at carbon number 7. Then we equally have other substituents. We have in this carbon, we have chlorine. In this carbon, we have iodine. But first of all, before we check other substituents, the numbering starts from omega carbon because omega carbon is very close to alkanol functional group at this carbon here. Then when you compare it from this alpha carbon to this one now, so the closest one to the carbon end is this one. So that is why the numbering starts from this place down to this place. So now, in the other substituents, like as I said before, at carbon number 1 we have chlorine, carbon number 2 we have iodine, carbon number 3 we have two substituents which are alkanol functional group and methyl. At carbon number 5 we have only propyl as the substituent. At carbon number 6 we have neobutyl, which is the only substituent. At carbon number 7 we have alkanol functional group. At carbon number 8 we have isopropyl. At carbon number 9 we have double chloride. At carbon number 10 we have two substituents, ethyl and methyl. Then the last substituent is the one we have at carbon number 12, which is bromine. Then having seen all the substituents, then the naming will go by alphabetical system. The letter that comes first, followed by others. Then the first letter here we have is the one that will give us a bromine, that is B for bromine. The next one is C for chlorine. The next one is E for ethyl. The next one is I for iodine, that is iodine. The other one that follows is isopropyl. The other one that follows is methyl, which is double at carbon number 3 and the carbon number 10. The next one that will follow is N, which is neobutyl. The last one is propyl at carbon number 5. Before we now have the parent name that will go with alkanol functional group. So in that case, we now have the name written. So the name goes like this, based on what I just explained now: 12 bromo, 199 trichloro, 10 ethyl, 2 iodo, 8 isopropyl, 3 10 dimethyl, 6 neobutyl, 5 propyl, chlordecan-37-diol. So that is the structure of the organic compound and the name. Thank you very much.